going to spend the next 20 minutes to give an overview about our work on the security reference architecture of IoT systems. My name is Kwok. I'm Professor of Computer Science in the Nanyang Technological University. This work is a collaboration between our laboratory and the cybersecurity agencies of Singapore. And the objective is to develop a security reference architecture for IoT systems in the smart nation applications. First, about the motivation. The purpose of this work is to propose a generic IoT security reference architecture to assist in the understanding of the security requirements and security architecture design. We aim to promote the common understanding of interaction model, system model, the things and or the components model across IoT applications. And the outcome of this security reference architecture study is to aim to provide guidance in the selection of securities or in the selection of standard security mechanism levels uniformly across an IoT systems. Now, first, before we start, we need to look at what are the fundamental difference between IoT systems and ordinary enterprise IT systems. So the IoT characteristics that amplify the security challenges are something that make IoT security a lot more complicated than the relatively better understood IT systems. First, from the angle of system. Now, IoT systems involve a wide variety of devices collecting data of varying sensitivities and are connected through highly heterogeneous network. And from the angle of the operating environment of the devices, now unlike traditional IT systems, we have these IoT application systems, as mentioned before, involving a lot of IoT devices, which are generally deployed in an uncontrolled environment, where communication mostly takes place over open networks. Now, this is fundamentally very different from traditional enterprise IT systems, where we tend to have a well-defined perimeter, and within the perimeter, physical security and control can be applied, and therefore we can have a relatively trusted environment. Whereas in the case of IoT applications, the devices, which is an integral part of the IoT systems, are deployed in such an uncontrolled environment. So we can't really make assumptions about the security or the trust of individual devices. And to make things worse, we look at the constraints of the IoT devices. So even though IoT systems are deployed for sensitive operations in field, lightweight nature of certain devices also pose practical constraints on performance, reliability, and security. Now, which means due to the lightweight nature of IoT devices, it may not be realistic or feasible to apply traditional security mechanisms on IoT devices because of the computation power in addition to the physical security control that is available to traditional IT systems. And another aspect is the identity of devices. In traditional IT systems, almost all the security mechanisms is based on cryptography or authentication, and ultimately it relies on the notion of identities of each of the entities in the systems, whether it's device, servers, or users. Now, in the case of IoT systems, assigning identities, authenticating identities, and verifying the role and privileges of the identified entities in a heterogeneous perimeterless network is a lot more complicated. Now, take note of this distinction, that is the heterogeneous perimeter networks, which is, as mentioned before, is very different from traditional IT systems. So overall, the IoT fabrics are extremely porous and with obscure and often unclear attack surfaces. Now, because of that, it is even more important to address the IoT system security, uh, given all these security challenges. And also, it requires a different way to look at the IoT security because of the fundamental differences from traditional IT systems, which means a lot of security mechanisms and designs that was developed over the past 20, 30 years for traditional IT systems may not be applicable. So given these security challenges, now let's look at a comparison between the traditional enterprise versus IoT security. First is the IoT devices lie outside of the traditional endpoints and computing nodes and interact with the physical world in a very different manner compared to traditional IT devices. And also, as mentioned before, due to the operational requirements in the field, many IoT devices must comply with stringent demand for performance, reliability, and resilience, quite unlike those in enterprise IT systems. And also, IoT devices are deployed in uncharacteristic locations uh, that need to be handled very differently from traditional IT devices in terms of management, monitoring, and servicing. And also, many IoT devices do not provide sufficient visibility into their operation, say software configurations, etc., unlike typical IT devices. And another characteristics that we identify is that in contrast with typical IT devices, the capabilities of IoT devices are fairly limited in terms of the features and support for customizations, in terms of specific customized security mechanisms that could be deployed or implemented for the particular security considerations. And given all these considerations, the security challenges of IoT applications um, can be depicted in the following areas. The first is large-scale deployment of IoT devices. Now, as people expect, for example, like the deployment of surveillance systems involving lots of IP cameras, the large number of devices will make all sorts of security design a lot more complicated. Scale is always a a factor that complicate security design. Second is that IoT nodes are geographically distributed, which further makes security design more challenging. And in terms of IoT networks, as mentioned before, um, there's diversified data transmissions of varying sensitivity, which are being delivered over the IoT networks. So again, it makes the security requirements more complicated, and it is very difficult to have a one-size-fits-all security mechanisms design. And also the data processing will have to happen in a complex threat environment, as mentioned, because of the fact that IoT devices tend to be deployed in uncontrolled physical environments. Now, because of all this, we need to go back to the basics. So what are the security design principles? Our design principle is basically make use of the zero trust principle. As mentioned, the distributed, open, and porous nature of IoT fabrics does not allow valid assumptions to be made on operating environments of IoT systems. Now, as such, the zero trust principle becomes a key tenet in securing IoT applications. And the key characteristics for securing IoT systems in a zero trust environment include specifically uh, the need for identifying the most critical and crucial and sensitive assets and services that need to be protected stringently. And we also need to strictly enforce identification, authentication, authorization, encryption, and monitoring mechanisms for such critical and sensitive uh, activities, which basically are the activities that process such data. And the design goal based on these zero trust principles include that we expect to have strong authentication mechanisms before an entity is granted access to sensitive resources or services. Now the question is, how can this be achieved? The other is the origin authenticity of data to be verified before being accepted for supporting decision making is important. And again, given the security characteristic of the IoT systems, how this can be achieved will be another challenge. And thirdly, the schemes and mechanisms for assigning identities and verifying the roles and privilege of the identified entities to support strong authentication is another design goal. So the data generated or processed outside secure perimeter, microperimeters could only be taken as a reference and should not be relied on for critical decisions. Now, we first talk about the fundamental difference between the enterprise IT systems and IoT systems. And then we look at, because of these characteristics, and yet, given the need for deploying IoT applications for meeting the needs of smart city applications. So we defined a number of security objectives or the design goal for the security architectures. So given all this, then what are the security challenges? What we identified from our study is that we need to provide means for system owners to determine the sensitivities of the data and the criticality of the activities that process this data. And sensitivity may be inherent to the nature of the data or due to the environment within which such data are acquired or due to the nature of the data processing. And another challenge is to develop a holistic and modular framework for risk assessment and analysis for security requirements. And we need to effectively apply a risk-based security design when deciding suitable control measures for meeting the security requirements. And we also require to have a flexibility to configure the security levels and control measures based on current standards that commensurate with the practical risk of IoT systems. Now, to address all this, we have gone through a very difficult process of finding a correct design architectures for IoT systems that would allow us to address the security in a more systematic and holistic manner. So because of that, we also explore the different architectural regimes for IoT systems. So with this, we started looking at the IoT architectures, and in the research community on IoT systems, there are basically three different perspectives, uh, namely the things-oriented perspective, that is, they focus on the functionalities, limitations, and characteristics of the devices or the things. On the other is the internet-oriented perspective that focus on the network integration platform, supporting connectivity of devices into an application systems. And the third perspective is the semantic-oriented perspective that focus on the data and knowledge created from the processing of this data. Now, starting from these three different perspectives that we adopted from the IoT research community. So in our work, we have devised an organized approach, namely the A and T centric approach, based on each of the above perspectives to study the characteristics of IoT applications. So what are these A and T centric approach to IoT security architecture? The first one is the activity centric, the A. So for studying the criticalness of the activities on different nodes based on the sensitivity of the data identified from the semantic oriented perspective. Now this corresponds to our earlier design goal about identifying the critical and sensitive data that are being processed. And the processing of such critical and sensitive data, we call this the critical activity of the IoT systems. And these are the activities that we need to find all possible means to protect them in a zero trust environment. And the other approach is the network centric. That is, for the highly complex and heterogeneous problem of IoT systems, is analyzed based on the openness of the network zones and appropriate security control mechanisms that can commensurate with the risk and exposure of the network environment. So basically, the key thing is to identify inside in the whole IoT application system, what are the underlying network infrastructures that connect all the IoT devices, edge nodes, backend nodes, all the nodes, and what are the network segments involved, or what are the network technologies involved, and which are the network components that are operating in an open environment. So based on this, whenever there is an open network, then we will have to apply the corresponding security control that reflect the risk inherent in the open network environment. The third is the things centric, for analyzing and understanding the nature of issues where data is captured in a distributed, open, and seemingly resource constrained environment. Now, this is our design methodologies. We start with identifying and studying the possible IoT devices within the applications. Of course, we have to start with the anticipated IoT applications in a smart city scenario. And then we look at what are the possible IoT devices within the applications, what are the processing capabilities of those devices, and what are the communication capabilities of the devices, and how critical the data are when being processed or captured or acquired by those IoT devices. Then we go through the process from the functionality of the IoT applications to look at what type of IoT devices should be required, and then we look at what are the network connectivity. Then we look at the network-centric architecture. And then from the network-centric architecture, we can identify or study the attack services. And from the attack services, we define the security requirements. And then from there, we recommend control measures that specifically assume a zero trust environment, but put a lot of emphasis on the protections of critical activities. So these are the design methodologies for our security reference architecture for IoT systems. So at the end, we develop a reference architecture based on the ANT-centric requirements of IoT applications. And I talk a lot about criticalness or criticality of the activities. These are components of an IoT application systems that perform critical tasks which involve processing activities of varying degree of sensitivity. Now, as certain activities entail specific security risk, protection of a component must be tailored to the criticality of the activities performed on the component. And our activity-centric technical architecture design propose the definition of abstract classes of activities and the specific risks associated with them. And then we recommend appropriate control measures for each such class of activities and the description of the protection mechanisms under consideration for the desired level or for the desired security level. Now, this gives you a overview about the outcome of the IoT security reference architecture, which also reflect the ANT-centrics, where the A is basically the critical activities, and it's basically reflect in the protection of the processing nodes. And the N is the network. So you can see here with the network segments and what are the security control. Once we identify the network-centric architectures, then we do the risk, the attack surface and studies, and then we define the security requirements accordingly. And then it's the thing-centric, that is the IoT devices itself themselves. So this is the overview about the reference security architectures, and a copy of a copy of the full IoT security reference architecture study report is available from our website for download. So to conclude, we performed the comparison of the classical IT paradigm in contrast with the Internet of Things paradigm in order to identify distinguishing security characteristics of IoT systems. And we also performed comparative study that revealed that the open system security model based on underlying zero trust principle is needed to govern the security architecture design of IoT systems. And that translates to the observed distinguishing characteristics into features and requirements of the appropriate system architecture design. And we determine the architectural features of IoT systems that are most relevant to the security by design of IoT applications based on the activity-centric, network-centric, and thing-centric views. And then we designed and developed a generic framework to identify suitable mechanisms to implement appropriate control measures to meet the security requirements at individual nodes of the IoT systems. And in our research, we also instantiated and verified the reference architecture in order to verify this generic framework using the practical use cases from large-scale IoT implementations like smart city, namely the smart lamp posts, smart metering, and smart home. So with this, I ended my talk, and I'll be happy to answer questions after this.